In this video, we're going to calculate the future value of an ordinary annuity when the cash flows occurring at the end of each period are uneven. In the previous videos, we have seen an example where the annuity amount at the end of each period is a constant amount of $1,000, but sometimes people may not be putting in their account the same amount of money every year, and they may put the different amounts of money. So when this is uneven, we have to we can't use the formula. So the formula we used when this cash flow series of cash flows occurring at the end of each year are even, the formula we've used is FVN A multiplied by 1 plus R raised to N minus 1 divided by R, where A is, of course, the annuity amount. And this annuity amount was the same year after year, but in this case, we don't have a single constant same annuity amount being put into the account, and these cash flows are uneven, or they're different year after year. So what we can do is there's no formula in this. We cannot use this formula because of this different amounts. So what we can do is just calculate the future value of the annuities for each year and then just add them. So let's see an example. So so let's just title this as a series of unequal cash flows and their future value at 5% interest rate, right? So let's say we have time, here, we have cash flow here in dollars, and we have here future value at year 5. Let's say we want to calculate the future value of the annuities at the end of the 5th year. So now let's have t is equals to 1, t is equals to 2, t is equals to 3, t is equals to 4, and t is equals to 5. So now our equally spaced periods are years. For example, from T1 to T2 is 1 year long, from T2 to T3 is another 1 year long. So this is a yearly and equally spaced time period where that equal space is a year. We're not using month or quarter. We can use different time periods. But for this example, as in similar way with the previous example, we're going to use a year period. So just to clear up some confusion, when we say t is equal to 1, for example, are we referring to the end of year 1 or the beginning of year 1? It's the end of year 1. So the beginning of year 1 will be t is equal to 0, which we don't have here, right? So whatever time periods we have, they are year end period. So t is equal to 1, end of year 1, t is equal to 2, end of year 2, t is equal to 3, end of year 3, and so on. So let's say at the end of year 1, which is at t is equals to 1, this person puts into his savings account $1,000. And at the end of year 2, he puts $2,000. At the end of year 3, he puts $4,000. At the end of the 5th year, he puts $5,000. And at the end of the 5th year, he puts $6,000. So we have to calculate these future values at the end of each period and sum them. So what we can do is, for this, we're still going to use the formula FV is equals to PV 1 plus the interest rate R raised to N. So what we can do here is that $1,000 present value times 1 plus 0.05 raised to 4, because between T1 and T5 we have 4 years. 1, 2, 3, 4. So 4 and so on. So this will give us a value of 1,215 and 51 cents. And the same way we're just going to keep doing calculating the future value for each cash flow occurring at the end of each year. So 3, and this will give us 2,315 and 25 cents. For this one, we have 4,000, 1 plus 5% interest rate raised to 2, because this is going to be for 2 periods or 2 years, and this is going to be $4,410. Gonna do the same with 5,000, 1 plus 0.05 raised to 1, and this is going to give us 5,250. And the last one, this is occurring at the end of the 5th year, and no interest will be calculated on this one. So the value of this is just 1, 0, and the value of this will be 1. 1 times 6,000 will be 6,000. And when we sum these amounts, we're gonna find 19,190 and 76 cents. So if we have a series of cash flows that are uneven, this is the only thing we can do. We can't use a formula. So at the end of the 5th year, this person will have about $19,000 and an account that pays 5% interest rate that is compounded one time per year.